Hello and welcome to 10 SAS procedures to commit to memory. I'm Dr. Mark Williamson for Transcend. Let's get started. So the idea is if you're working in SAS, coding, doing statistics, you'll use certain procedures over and over again. So it might be a good idea to commit them to memory so you don't have to constantly look them up when you haven't done it for a little while. And so these are the 10 procedures that I've identified in my work that I think it would be helpful for me to commit to memory. Maybe this helps you as well. So the 10 I'm looking at here, importing, creating, and printing data, then summarizing data, then kind of combining two means and frequencies. So I have room for number 6, transposing data. From there, there's sorting data, creating new variables, plotting data, and then finally modeling data. And almost all these methods are procedures, so the proc, and then followed by the name, though a couple are data sets, so the creating data and creating new variables data. So let's dive into what that looks like, and then we'll finish up with some real examples with a toy data set I have. All right, so some color coding. I'm trying to follow what it does in SAS Studio. So anytime it's black or colors like that, it can be data dependent. It'll be what you need to put. So a lot of times I'll just have sort of dummy variables like data set, but you'd actually put whatever your real data set name is or your real treatment variables or your whatever variables you're actually named. Whereas things that are blue, whether it's dark or light blue, those are going to be data independent. Just by policy, to keep my code clean, I capitalize procedures and data steps. So proc limits will be all capitalized, whereas the statements are going to be lowercase. You can do what you want, but that's how I do it to kind of keep things clean. Strings in SAS Studio are this off purple, while numbers are this off green, and I try to replicate that in my example code here on the slides. All right, first step that you should probably memorize, importing data. That's probably the most important and first step you do for anything. And so you're going to use the proc import statement. You're going to have a data file or proc import procedure. You're going to have a data file statement. Now, this will be whatever your file is, and this will be different whether you use SAS Studio or just sort of base SAS. I use SAS Studio, so it's typically going to be a file that I've downloaded to a folder on my SAS Studio, and I need to make sure it goes to the right one. Then you're going to have this DBMS, which is going to tell SAS what file type it is. I usually use a CSV, so that's usually going to be a CSV here. And then the out will tell you what you name it. So when you reference it later, so for this mock example, it's TP, so 10 procedures data set. And I almost always use replace as a optional statement. So it'll replace the data set. So if I reload it. Another couple important options is get names. So you have your variable names. I put yes. And this is a really important one that I often forget and then I have to come back to and I should really memorize is this optional statement called guessing rows. Because essentially when you load it in, it sort of guesses for, especially for categorical variables or class variables as SAS likes to call them. It'll it'll sort of look at the first couple rows and decide, okay, this is probably how long the names are. So say you have like treatments and it's like, or maybe say plant types like alfalfa, barley, wheat, or something. And if it's not sorted in a certain way, essentially it can cut off variable names after a while. And so what I like to do, if you do put this to a big number, larger than a data set, it won't just sort of guess the first part. It'll have to go through all of it. So that helps keep variable names from being cut off. Anyways, it's a little niggly thing, but I think it's a really important thing that I try to remember. All right, moving on to a second important one. So if you're not importing data, you need to create a data set. There's a couple of different ways. I typically use the data lines. And so you're going to use a data step. So data, and then you're going to, whatever you're going to call it. So say this is data set 2. And then you use input and then data lines. So again, there's a way to do cards. I like to use data lines. And so your input is going to say what are the variable names and their types. If they're class variables, you're going to need to have the dollar sign after it. If it's just a number, you don't have anything after it. And so for a very simple one, just fill it out from there, then have a semicolon at the end. And so names, so this would be Mark, Chad, Beth, and Lily. Those are class variables. Status, even though these are numbers 0 and 1, I want it to be considered a class. So I have a $sign after that to show that there's that. But then the last ones are just numbers. So I just have them as numbers. So there we go. Pretty simple. Typically, you're going to be importing bigger data sets, but for smaller things, sometimes creating your own data makes sense. All right, another really important thing, something you're probably doing a lot, and maybe immediately after importing your data, is going to be your proc print. So you're going to tell with a data statement what your data is, and this is an important thing that sometimes I forget. So this is what I really want to remember with proc print is if you put in parentheses this optional statement of obs and then equal, you can actually print a subset. So say you have a really large data set, it might be helpful to just look at the first 100 observations rather than everything. But for smaller data sets, you probably just can do print like normal. All right, next thing here is summarizing data with proc summary. You can, again, almost all of these use these data statements. Now, if you don't include a data statement, I believe SAS defaults to the last one you use, but with good practice, I always clearly define what data set I want to use. And then you're going to have couple statements. You can have a by statement and a var statement. So the var statement is what numerical variable you're going to summarize, and then the by is like what's it by. So for example, you have number, maybe it's growth, and then you want to look at, say, plant categories and treatment categories. Now you can have a single by statement. It's variable in the by statement. I'm just showing you as an example, you could have more than one. And then you can actually do an output. You can output this to a new data set. So output out equals, and then whatever you want to call it. I usually call it some like sum, to summarize. And then you can print that from there. So that's really helpful. And the summary has things like the number, min, max, mean, I think median, standard deviation. You can customize that, but sort of out of the box, it just gives several common summarizations. Now, something very similar is proc means. It's very similar. It's slightly different sometimes with the biggest sort of visual difference is the output, but I put it here along with frequencies. So proc means very similar here. You can do by statements and a var statement. You can do an output statement too. Typically how I run it, I usually are just looking at the mean, so I don't put an output, create an output data set, but you certainly can. Very similar. The same way you would do it with proc summary. And then proc frequencies, that's really helpful for count data. So that's why I kind of have it as a natural complement to the mean. So the means is for numerical, frequency is for count data, so categorical data, and you're going to use the tables statement. You can do a single table, so look at frequencies between one class variable, or you can do two-way tables or even three-way tables, but two-way tables is probably easier to look at. And so here's an example here doing cat1 by cat2. All right, transposing data. This is some of the trickiest, but some of the most helpful. So you use transpose, and this is where you're going to have your data, what you're loading in, then you're going to create a new data set. And by sort of good practice, I like to name my output data set, whether it's wide or long. You can transpose it either long way or wide way. You can do either way. I typically find going from long to wide is more common because I usually start with a long data set, and if I need to have it wide, I transpose it here, but you can do it the other way. And so you're going to have a by variable. That's the variable placed along the rows. The ID is going to be the variable placed along the columns. And then the var is going to be the variables placed within the data set, and this can be multiple ones. And I think technically you can have multiple categorical variables, but that's a little more complicated case. I'm just showing the simplest case here. All right, sorting data, and we'll see in the actual example. Sometimes you need to do this earlier than what I'm showing here. So this is not necessarily in chronological order, but anyways, we'll go with this. So it's going to be proc sort. Again, very similar to a lot of the other ones we've seen. We're going to have a by, so where you have your class variables. And really, that's all it's going to be. You're not going to have a var statement. And you can have a single categorical variable that you sort by. You can have multiple ones. It really depends on what you need to do it for. All right, create new variables. There's a variety of different ways here, but they're going to be using a data set. And you can create a new data set from here, but simply usually I just update it by using calling it the same name as the data set I set it from. And now for a new categorical variable from some sort of setup for my old variables, I usually use an if, else statements. So essentially what you can do is use an if, you can reference an old variable you have. So cat1, say it's A. I want to maybe update these. I can say then do and create a new variable called cat2, and then what are my new classifications? So maybe A's, I just want to turn to ones. Do that. We have an end here. Else if, maybe B's I want to do two. And then anything other than that, I can do an else do for all the other cases. I just want to, it doesn't matter what their cat1 is. If they're not A or B, they're going to be three. So you can use that. And this isn't complicated, but it's definitely nuanced where you have to have the right statements, you have the right semicolon in the right area. So it's definitely helpful for me to try to memorize this. Now, it might be another common way to create a new variable is more numerical, where maybe you say number two and you're already referenced variable in the data set. Maybe you just want to add 10 to it, want to add a constant variable to it, or maybe you want to multiply one variable with another or add one variable to another. You can do that too. It really just depends on what you need. All right. Plotting data is probably the biggest one, and this is just be very simple. If you actually want more details of plotting really nice graphs, I have a whole training set for that should pop up somewhere. But you're going to be using proc sgplot, give it your data, and then depending on what variable so you have, what do you want to plot? It's going to be different statements. So these are the most common ones I use. So histogram, you just need a numerical variable. For VBox or a vertical box plot, you're going to need a numerical variable, and then typically you want to compare it by category. So you have a backslash category and whatever categorical variable. You can do multi-way plots, but this is just the simplest example. And for a scatter plot, you're going to have a y, numerical y variable, and numerical x variable. And then probably the most involved, though usually most helpful, is bar plots. And typically you're using not just your data set, but some sort of summarized data, whether from a model, which we'll see in the next one, or if you use like a proc summary or a proc mean statement and saved it as a summarized data set. And you're going to use vbar parm, so vertical bar plot with parameters. Your category, it's going to be whatever categorical variable you're comparing across. Your response is going to be that typically with how you run a model, it's going to call this variable estimate, which is essentially the mean. It's usually what you're applying your means, and then you can have a backslash and have a lower and upper confidence intervals for the actual error bars. So that, and then finally modeling data here. Again, this is very simplified, but I almost always use proc glimmix because it's generalized linear mixed models. It's so flexible. You can use all sorts of other regret models like ANOVA, t-test, all sorts of regression, logistic, Poisson, etc. And you can also involve other distributions. You can use random effects. So this is really the big package here. And I have a whole training about that as well if you want to look into it. So you can have a class statement for your categorical variables, your modeling variables. So it's going to be your y variable here equals, and then whatever your x variables. You can have numerical variables, categorical variables, as long as you have them in your class statement. You can have not only categorical variables on their own, but if you have a bar here, it's on their own and their interaction. You have a backslash here to get an optional solution and change distributions. By it defaults to normal, but if you want if you know it's a Poisson distribution or a binomial distribution, you can put that here. And then if you have random effects, you can put that here like block, and then a backslash, you can also have an optional solution. And so that's sort of not the simplest Glimmix model, but a model that includes a lot of the basics that you might have in building up a more complicated model. All right, with that, we've gone through the 10 that I think are most helpful. Let's look at them in action here. Here we are in SAS Studio. This is where I do almost all my SAS coding. It might differ a little bit for you, but SAS Studio is really helpful. It's free and helps you keep track of things with its files and folders. Anyways, so here's the first example here of importing data. I created this little 10 procedure SAS test data set. It's a little toy data set about aliens. And so we can import it and then sort of print it right away here because we probably want to take a look at it quick. All right, so there we go here. We have ID, which isn't really going to be important later, but we have color of alien, so green and gray. We have type of alien, bug or humanoid, where what planet's from, Mars or Venus. And then some numerical variables, size, speed, and intelligence, and then a random effect, a blocking variable. So that's simply how you import data here. You actually have the right data file name, whether it's SAS Studio or just SAS. But there you go. I put guessing rows to like 10,000 to make sure I didn't cut off any of my, say, categories. Like, for example, if I would have not done that with type, it would have checked the first couple ones of bug and thought, oh, okay, this should be three long, and probably it would have cut it off humanoid to hum without this guessing rows. All right, second one, say I want to create data here. I'm going to use the data lines, create what I call alien supplemental long. This is just a pretend like way these observations were gathered, whether it was what agency, whether it was NASA, FBI, or Department of War, what method, telescope, satellite agent, and then the counts, so the number of counts across them. And we'll use that later for transposing. All right, printing data, we've already seen that, but say I want to use that optional observation, we can just get a subset of the original data set, and it'll just show us the first 10 observations. There we go. And that's really helpful for very big data sets. All right, summarizing data. Say we want to summarize by, we want to get summary of size by color. We can do that. And we can actually save that as alien sum. So let's do that. There we go. And because we have two colors, we have summaries for green and for gray. We can see here the different stats is N, min, max, mean, standard deviation. So that's for both. And however, now I mentioned that sometimes you need to use proc sort earlier. Say if I want to also summarize by type and planet to get speed and intelligence out and save this as a new one, but try to do this right off the bat. It's going to actually throw an error because we didn't actually have it sorted by type and planet. How I loaded it in, it was already sorted by color, so that's how it worked the first time. But if I actually want to do it with type and planet, I need to sort it first, so I'm going to use proc sort, then try that, and then print it out and see if that works. And voila, it did work here. And so you can see sorting by multiple setups here. It's taking a little while to open for some reason, but we can kind of see here. So we have both type and planet. So we have the summary statistics for bugs on Mars. So our 5 things here. And then because we also looked at 2 different variables as a speed and intelligent column. And so you can do quite a lot with summary statements. Now, for means and frequencies, so we're going to again sort by color now that it's no longer sort by color to get means of size by color. You can see here, again, means and summary can be very, very similar how they're set up. So we'll see how they look. They look a little bit different. See here with the means procedure actually have different subtables. So by color and color rather than mushing one table together, but we still have things like the number, so the count, mean, standard deviation, min, and max. See, there's very little difference between the size by color. And if we want to do a frequency, we can use proc freq, and we can look at color and also color and planet. And see that we'll get both a 1 and 2-way table. Here's the 1-way table. So there's actual equal numbers of green and gray, 20 each. And it gives other things like percent, cumulative frequency, cumulative percent. And then a 2-way table can also have that as well as row and column percent. And because this was a balanced design in the way it created the data set, we can see that there's equal numbers. So there's 10 from green and Mars, 10 from green and Venus, 10 from gray and Mars, 10 from gray and Venus, and with the total being 40. All right, transposing data, we're going to take our supplement long that we had before. We're going to actually sort it by agency so we can transpose it by agency and get out our counts by the various methods. And so we got here. So now we just have 3 rows. We have the 3 different agencies and then the counts across whether it's an agent, a satellite, or telescope that got the observations. All right, sorting data here. We've already seen this, having to do it for some of our necessary steps, but we'll just do it again and sort by block. You can see the whole alien main data set sorted by block. There we go. And so now it's block 1 through 5 sorted. All right, what if we want to create new variables? Say we want to have climate. We know that Mars is hot, so we're to say if planet is Mars, then change new variable climate to cold. If it's Venus, we'll do climate hot. We only have 2 planets, so we don't need this else do, but I just have this as a catch-all. Say if there's other planets, we would just put climate as other. And then we also want a more of a numerical one. Say maybe it would make sense to multiply speed by size in our old data set, and we'll create a new data set called speed size. And we can create that, and we'll have it here. And we see now we have our full data set. We now have that new climate variable and a new speed size variable. Looks like those are completed. All right, well, if we want to plot data here, let's look at the 3 simplest ones to start with. Histogram, box plot, and scatter plot. Look at different things here. So we have a histogram of size, a little bit uneven distribution. We have intelligence by type. So it looks like humanoid are much more intelligent than bugs. And looks like there doesn't really seem to be much of a correlation between size and speed. Obviously, we can do a formal test, but a lot of times graphing, we can eyeball general trends. All right, a little more complicated one. We're going to want to do a vertical bar plot, but actually, so you could have summarized it data by like proc means and then get things in here. But typically what I'm doing when I'm plotting a vertical bar plot is after I run a model. So I'm going to run a Glimmix model. The details here, we'll talk more about Glimmix in a moment. But essentially, I just looking at speed as a function of planet and type and their interaction. I can do an LS means. We didn't really show this in the simplest one, but this is a way you can get LS means of the interaction and then output it as a summary. And so let's just, how we got it isn't the most important. It's just the fact that we have these estimates I want to show you, and then we'll plot them. So of the model, but essentially we get this data where we have planet and type, and we can get the mean essentially of our what did we look at here again? Sorry. We're looking at speed, and we're looking at speed across planet, Mars, Venus, or type, bug, and humanoid, and then we have our mean. The estimate essentially is a mean here in this point, and then we have our lower and upper for our error bars. And so we can take that, call it, we're looking at planet, and then grouping by actually type. We didn't show this as well, but you can make a 2-way bar plot, and then lower and upper to get our little error bars. And if we do that, we did our job correctly. It should plot fairly nice. There we go. Bar plots with parameters who have our error bars. And these are 95% confidence intervals. We look like there's really not much difference in speed. And finally, modeling data, doing that more properly. We have proc Glimmix, and say we want to see is if intelligence is a function of size, color, and type, with color and type being our class or categorical variables we need to put up here. Say we have a normal distributions. We have this random effect of blocks, so we're going to include that in here. And again, the actual output isn't what we're trying to like decipher. We're just showing what sort of dummy code looks like. I have a whole training on generalized linear mixed models for everything if you're really interested in more of the details and parsing through what the responses mean. All right, we've gotten through our 10 procedures in SAS that I think you should memorize, and maybe more importantly, I should memorize, and maybe My work here in trying to memorize them will help you as well. We learned how to import, create, print data, as well as summarizing, getting means and frequencies. From there, we learned how to transpose, sort data, even creating new variables, numerical or categorical. Finally, plotting and modeling data. Thanks for joining me for this training session. I will see you next time.